Okay, so welcome everyone to this webinar on digital modeling for railways. Sorry for all the technical issues. We had some issues setting up the interpreter. I understand that it should be okay now. So without further ado, I will give the floor to François Daven, our Director General for UIC.
Okay. Yeah. Okay. Thank you very much. I'm quite honored to do the introduction today, and I should say that this question of modelization is quite dear to me because, to say the truth, I'm quite old sci-fi reader, and I do think that what you are doing collectively, and in particular in UIC with all those models, it's beginning to implementing something that has some kind of flavor of the future, because you are implementing the tools to glue all the different modeling tools, and at the end of the day, I think it will be able to really be able to have a complete vision of what will be the railway system. And I do think we are all speaking a lot about digitalization that will change whatever, basically. I think we perhaps are not concrete enough. Perhaps a paradox to speak about concrete things about digital modeling, but I do think that there we are really in the concrete work that will make possible to have at the end of the day digital twins, to have a massive utilization of artificial intelligence, and at the end of the day, to be able to develop the digital services, and more generally speaking, a level in efficiency on the transport services that we have not known until now. And I do think that's very important that we do collectively this work, because as for any digital question, the first that will be proposing the right tools, that's tools, that is the right word. There will not be a single model, but that will propose the right framework will be the one that will lead the industry for this very crucial task. So in a nutshell, we have to implement our modeling tools before to be modeled by someone else. And that's really important that collectively we are, in a way, modeling ourselves. And I do think that, indeed, UIC is the right place for doing that, because we are neutral. We have all the networks, in Europe and also all over the planet. So that's today a very international webinar, and I think that there is good reason for that. And I think we have we are the good forum for the sector to find himself the way to model himself. Well, my second point will be to say that after all, it's quite an old idea to have digital models for everything. I made a few research, and I think the first novels that were about it is, I don't know if some of us read it, is Simulacron 3. That's a roman for Daniel F. Galouye. It's from 1964. And the story is about a world that is simulated. So there is some kind of plot, the idea, the basic idea is that the reality can be simulated. So that's quite an old idea. And what we are experiencing now is that we have the technical tools for indeed beginning to make it into a reality. Well, so you will have a lot of very technical presentations, so I will not enter into the detail. But I think for UIC, what we are working on is the RailSystemModel, which is a generalist functional model for the railway system. There again, it's a backbone to federate special digital modeling, and and initiatives like Eulynx for signaling, IFC for construction, and there is other. And the idea is to provide reusable building blocks. So I will not enter into detail. I think you will have a very interesting presentation about that. But I think the idea is really to bring there the frameworks that will enable to do this digitalization and this mobilization. Then we have also OntoRail, which is an encyclopedia to consolidate and enrich railway system modeling knowledge. That will be a tool that will promote and facilitate convergence and federation between models. Well, so I think these are really powerful tools. That's a little bit difficult to explain what it is exactly, so I will let that to the specialist. But I like well, something that I've been told speaking with those strange guys that are developing things in UIC, that it is a way to see a system using all the different angles. Meaning that when you are looking at an object, well, there is always different faces, and those ontologies are in a way the way to aggregate and to be able to see one particular part of this object. Well, I hope that the explanation is not completely out of well, as an actual meaning, but I do think that that's very important, since we have a very complex system with a lot of angles, and what we are trying to provide here, and that's the reason why I do think that UIC is the right place for that, is to reassemble all those different way of seeing the system, integrate them, and making possible at the end of the day to have those digital twins that will be the very practical tool for progressing in digitalizing our whole system. So that would be all for me. I understand that we are a little bit delayed. Well, thank you for your attention, and well, I look forward to hear also myself to those very interesting presentations. Thank you very much.
Thank you very much, François, for this introduction. And so just to make up for time, let's move directly to the presentation of RailSystemModel by Eulynx from UIC.
Yes, good morning, ladies and gentlemen. In consideration of the translation, I will try to speak slowly and in a few words. So let's jump directly into RailSystemModel. There will be three parts, some fundamentals for those who never met it, some highlights about the evolutions since the last few years, and then some application cases from different European projects mostly. So let's start with what is RSM, RailSystemModel. Well, you can see it from different aspects. For one thing, it's a simultaneously conceptual and implementable model of the railway system. At least it's our ambition. A conceptual model because it is quite abstract. Each concept is embodied by one class. So people seeing RSM for the first time will say, well, this is a strange model. There are hundreds of classes and they are all empty. Yes, it is indeed the case, because we try to isolate concepts, and then they do not need to carry many attributes in order to be identified. This is, by the way, a way to bring the model closer to ontologies, and this is very practical. On the other hand, the model is implementable and not even project specific. It's quite project independent. And you will see examples of RSM implementations later on. So for sure, if you look closely at the model, it's written in one formal language, which is UML, which is quite widespread, especially for code specification tasks. So definitely it is suitable for code and scheme generation. Java or C# code, for instance, and scheme generation like XSD or JSON scheme. By the way, RailSystemModel has now two presentations. One is the UML. The other one is the ontology file, the TTL file, which is using web ontology language syntax. This ontology image of RailSystemModel is a true image. It is derived automatically, and normally you should find every single concept construct that is in UML also in the ontology field. It's an equivalent. And last but not least, Rail System Model is an initiative by UIC, already embodied by an international railway standard. It was first published in 2016. And there will continue to be published live on the website, rsm.uic.org, and also later as an electronic IRS, an EIRS, Electronic International Railway Standard. When I say, well, the ambition of Rail System Model is to describe the railways, well, certainly not alone, certainly in conjunction with other models. And the current coverage of Rail System Model is certainly not covering all activities of railways. On the other hand, we take care that this should be possible if there is a business need. So for the time being, on this graphic, you see that I've sorted out the business capability levels of the railway system from the bottom, that is the individual components, through subsystems like track signaling telecom, then up networks, because you assemble subsystems to constitute networks. Then, of course, networks are used, operated and maintained, and tickets are sold to passengers to make business out of it. So for the time being, the blue zones here are those that are pretty well covered by Rail System Model. That is basically the network level. Well, initially the model started with a kernel that was, well, the topology of the network. So I would say for that network level, we cover pretty everything that is needed, from design through construction to evolution, decommissioning. Subsystems are partly described. We also rely on others, components too. Operations and maintenance have started to be addressed by Rail System Model, and the nice surprise, well, not really a surprise, but fact is it didn't disturb the foundation layers that had been laid out in the past few years. And as I said, well, we are not working alone here, because for the description of subsystems, other projects went on, also with the participation of UIC, by the way, like IFC Rail, Industry Foundation Classes for Rail, under the authority of Building Smart International, and with a very strong participation from China, by the way. We have, especially for the signaling interfaces and configurations, a Eulynx model, which is very powerful, and with whom we have been cooperating since 2017. For operation planning, for instance, other models would be, I would say, nearly natural candidates to complement Rail System Model, like Transmodel, which is an ISO standard or a SENS standard. For traffic management, there are lots of ATO projects, and here I mentioned the SNCF ATO projects for freight and passengers only because Rail System Model is already integrated in it, but of course, it's certainly not a single case. And for the commercial part, well, as I said, Rail System Model has also a ontology personality. And here we are aiming at ontology specialized for commercial transactions for passengers, like the START ontology that has been defined for shift to rail. Also, by the way, with the participation of UIC in this open call project. So, as I said before, we started very much works already in 2014 with the network description, and this explains why the topology kernel of Rail System Model still plays an essential role, a pivotal role. And here it's a bit exotic compared to what most other models will propose. In most cases, infrastructure networks are represented with the graph model with nodes and edges. And typically in the railway world, it's seen natural to say, well, the nodes are the crossings, the junctions, the stations, and the edges are the lines and the tracks. Well, in fact, we reverse the perspective. we are putting lots of emphasis on the lines and the tracks, which is the bottom part here on this slide. And as you see, I represented schematically a track with a turnout. So you have the incoming track, the through track and diverted track, and the peculiarity of the rail system model is the relations between those three track sections are explicit and documented. And as you may know, between the through track and the diverted track, you cannot circulate a train. You would have to reverse the direction. And this is built into the model. That is, the constraints, the natural constraints of railway networks are well integrated by the model. And this enormously eases also the reasoning on the network, like for instance, finding shortest paths. But enough details. Let's come to a few highlights. The packaging of rail system model has slightly evolved since the last version. You still have two super packages. The one of immediate interest is, of course, infrastructure package with tracks, signaling, and energy subsystems being represented. Net entity being a, I would say, a service package that is used by the three others. But this infrastructure description rests on a basis that is called common, because it's also common to other models, including the other Eulynx model. And this contains lots of common concepts, integrates lots of common concepts like geometry, location, etc., that I will shortly detail afterwards. So let's start with the base package. Base is, as the name tells, very basic, and usually initially contained very few classes, essentially the general object classes carrying its unique identifier, essentially for allowing for disambiguating the model implementation. Is making sure that every object in the field has a replica in IT. So it's the idea of the numeric twin, digital twin. We have complemented the base package with two essential aspects, especially for engineers. One aspect is obvious, it's quantities and units, directly derived from SysML 1.2. Because as engineers, we like to talk about, well, quantities that characterize, for instance, a length with a unit, etc. We don't deal with figures. We are not interested in integers and float. These are IT concepts. We are interested in results of measurements. So quantities and units were absolutely essential for good quality information exchange. The other important aspect, also inspired by IFC Rail, by Eulynx Multi International, is we separated the notion of object from the notion of property. So a locomotive does not have a length. You observe that the locomotive has a length, and you bring those two pieces of information together. So the strict separation of objects like tracks, locomotive, etc., from their properties is also essential, because their life cycles are different. A locomotive can last 40 years, but the fact that it is powered or not, or its owner, for instance, will change several times in its lifetime. So it's not possible to have very difficult to have a working model if these are not clearly separated. The time axis is obviously derived from the OGC and W3C time ontology, so we'll not come back to that. The positioning is also derived from OGC standards. Sorry that I didn't mention that explicitly here, but definitely it's the case. And we have, in fact, in the model, three types of coordinates: intrinsic coordinates for schematic representation, linear coordinates that are most familiar to railway people, like kilometric points, or odometry that is measured by a locomotive that runs on a track. And then, of course, geometric coordinates for use with geographic information systems and CAD systems. The location package has always been there and was also criticized because it looked complex. Well, I think this location package embodies one of the fundamental characteristics of a rail system model. As I said before, a train does not have a length. A train does not have a position on the map. Fact is, you observe that a train has a position by GPS, for instance, or you observe its linear position using kilometric posts. The location package, the location class, in fact, will associate a physical entity like a train with a net element, a topology element. The train is on a certain line section, and bring also together the other information like linear and GPS positions. So these informations are not aggregated to the train, they are just observed about the train and its environment. Geometry is also has been introduced. By the way, what is green basically is new in RailSystemModel 1.2. Geometry was introduced in a very light and easy way. In fact, IFC Rail uses the IFC geometry packages and extended them with the lateral or the inclination or cant geometry. We have simply reused the classes prepared by Building Smart International in the course of the IFC Rail project and managed to connect them to only 3 very basic and fundamental classes in Rail System Model. Base object, which is quite generic for describing any object, physical or abstract, non-physical. And then spot location and linear location. I think you immediately understand what it's all about. And in this way, it was possible to couple an existing model with rail system model with minimal interfaces and well understood interfaces. Such kind of extension is easily repeated in other fields. Now, more importantly, observation and measure was probably one of the key additions to rail system model. Here again, we did not reinvent the wheel, but reused ontologies developed by W3C and OGC and published, of course, because we are keen to use any publicly available industry standard, and this is one more case. So what the semantic sensor network ontology says is basically an observation considers an object, what they call a feature of interest, which can be a milepost, a mountain, the Eiffel Tower that I just see right now. And then observes an observable property like, well, the height of the Eiffel Tower in front of me, and yields a value or several values. And this pattern, by the way, can be repeated for requirements, because requirements are also about objects and saying this is a nominal value of this property of that object. And then you can extend it also to predictions and saying for that object, I forecast then the value of that property in 2 years will be so much. Like for instance, the degradation of well, the repair state of the track, for instance. So we just extended the SSN ontology with requirements and predictions, here also in cooperation with strong demands from the IFC Rail project, and get to a very generic way to trace observations, requirements, predictions independently from each other, so that you can base a predictive maintenance system on the records you would make using rail system model. Net properties are also a concern that was expressed by many partners, including IFC Rail project. That is, sometimes we need to take a bird's eye view on the network and say, for instance, well, the network is electrified or that part of the network has narrow gauge. So for that purpose, you have somehow to project properties that you measure, like what is a gauge actually on that piece of track, and sum it up over a vast area. And this is the way you get to net or line property values as they may be expressed in the European Register of Infrastructure, for instance. So this is one very important use case because we all know that feeding the European Register of Infrastructure with data is a quite intensive and cost-intensive task. So the better automated, the best. And it's certainly not restricted to that particular register of infrastructure. Being able to compute and sum up a multitude of small properties is also of use for describing for instance, the general state of the network. Sorry to jump from one subject to another because there were many additions in RailSystemModel 1.2 compared to the previous version. Certainly now we have small packages for subsystems. These packages are meant to remain small and to facilitate interfaces to expert models, quite detailed models, like Eulynx data prep for signaling, or IFC Rail for, well, most subsystems, especially for their physical description point of view. So currently we've provided signaling, energy, and track, and we hope that we'll soon also come up with telecommunication, of course, in civil works, tunnels, etc. Finally, there is one additional super package that I missed to describe in the previous slide. We have now a super package for environment because all of a sudden we thought, well, maybe railways are a big world, but we are not alone in the world. And definitely for a specific purpose projects, we need to introduce legal entities and weather. In both cases, again, the principle was, let's not reinvent the wheel. Let's not make an ad hoc model to satisfy one or two use cases. Try to reuse what general vocabularies, ontologies in that case, were proposed by others. And of course, we found some, hopefully these are the best. For legal entities, there is ISO 27275 based on the GLEIF ontology. Sorry, I forgot what the acronym means. And for weather, a good candidate apparently was a climate and forecast vocabulary that also was transposed into ontologies that seem to be used by weather forecasting professionals. And this for describing phenomena and properties. So the usual paradigm, we don't mix up the objects and their properties, and they do exactly the same. Here again, the interfacing was easy. Now, to conclude, RailSystemModel is not just theory or additional niceties, as you saw in the previous slides. It is also running projects. First and foremost, maybe the Eulynx data prep project. We have been cooperating with Eulynx since about 2017, formally, leading to a very tight integration of Eulynx data prep model and RSM. But at the same time, although it's very tight, we also kept the model clearly separated and the responsibilities of each model owner totally untouched. That is, RSM is responsible for its part, Eulynx for its part, and the interfaces is clearly formalized and, by the way, kept rather simple. So here, this is a concrete example, at least our first test case of having a model federation. Well, the federation did not start with 6 like the European Union, but it started with 2. Well, it's still a good start and meant to expand because I think also the integration level we got with IFC Rail is not bad. Now, concrete projects were run on the basis of RailSystemModel and other models. One example is the Horizon 2020 SIA project, which is broadly speaking about predictive maintenance applied to pantograph catenary and wheel-rail interfaces, so between rolling stock and infrastructure. Here we again cooperated, in that case with DLR, Mr. Christian Ramik, I think he is in the room now, and agreed that we will use two different models. The kernel from RailSystemModel, at that time it was still called RailTopModel. This is only a rebranding, by the way. And then subsystem descriptions or bits and pieces of it from the RailML model, and managed to marry both models without any trouble. Anyway, RailML 3 is based on RailTopModel, and also managed to generate for the concrete purpose of data exchange XSD, XML schemas, that is, automatically from the source models, from the UML models. And you see the result as an illustration on the bottom left. So here I would say definitely a good test case and a good success. And by the way, also a good cooperation. Optima is a currently running project. It is a Shift Rail open call that aims at establishing a traffic management system. And we have actually two models running in Optima. One is the, I would say, the project-specific model, already prepared under the XRail 4 model, which is totally directed towards data exchange, but still based on RailSystemModel as a component of the common data model being prepared by Shift Rail. And here the actual service delivered by RailSystemModel was to, well, we had to cope with a piece of Italian infrastructure somewhere in northern Italy, for which the documentation was scarce in terms of drawings, etc. So the shortcut was to take the OpenStreetMap geometry, import it into RailSystem model, using a RailSystemModel instantiation written in Python. So it's code, it's working code. The import is, of course, automatic. And then the RailSystemModel applied to northern Italy has been, well, instantiated in memory. Manipulated there, of course. And from there, we got exports to the KML format, which is very good for displaying Google Earth and in ArcGIS, etc. And you see the display on the right-hand side. So you have a background, which is a map, in fact, a photographic view of the Italian coast. And the red lines are, in fact, the representation of the RailSystemModel net elements. You don't see all the details, of course, just a few attributes shown here in the window. From those net elements, we inferred the linear referencing system using a shortest path algorithm, and then generated a JSON export, which you see on the bottom left, that concretely shows how RailSystemModel looks like when it is running and implemented. And of course, here the things of interest were especially the linear referencing system, riferimento lineare binario nord in Italian, and with some anchor points where you see, by the way, the basic concepts of objects, quantities, units being used in real life, because again, we are talking railways, so we need all this concrete information and not just bits and pieces of data. That would be, I think, the end of my presentation. Sorry for the time slip. I tried to catch up a bit, and I think we did not miss anything essential, but after OntoRail comes to Word, we'll have a discussion session. So if you have questions, please reserve them for this discussion session. There is a good reason to have discussion after OntoRail. It is, again, because RailSystemModel and the RailSystemModel imports in OntoRail are two facets of the same tool set. So I give the word then to Mr. Didier Guillonnet. Sorry, to Pierre Tan again. Thank you. Yes, Pierre is switching the screen, the external screen monitor, and we'll be taking over in a few seconds. So sorry for the slight delay.
Do we see my screen or not yet? We see it now? Yes, okay. No. Okay, thank you. So, thank you, Harry. So now the second initiatives in digital modeling that we would like to introduce to you is the OntoRail tool, which is a project that from a project from UIC that was initiated back in early 2019. It was actually a joint project between UIC members and the UIC organization, but also with stakeholders of various digital modeling initiatives in the sector, such as Eulynx for signaling, IFC for construction, as well as also RailSystemModel organization. And the vision for that, are we on that screen or? Okay, so we are not where I think we are. So up. Yes, okay, now it's probably okay. So as I said, the idea was to recognizing that there were various sectorial initiatives of digital modeling looking at the railway system, but from slightly different angles. The idea was to identify a way to have a combined vision of the railway system across these initiatives, and as such to come up with an encyclopedia so that we could exchange and link related concepts between those various sector initiatives. The idea being that we have specialist projects looking at particular part of the railway system, and if we put them all together into one combined encyclopedia, then we enrich the railway system modeling knowledge. And further on, if we can start linking concepts between each of these various initiatives, we can further on enrich even further the knowledge by being able to have a digital continuity of the railway system information across the life cycle of the projects, for example, or also through the different facets, such as functional, structural of a given project. The second thing that we envisioned was required to build that vision of a unified and conceptual model was to have a tool to build that consensus, because we initially we have various sector digital modeling initiatives, and they will have some overlap. They will have some similar concepts. For example, the concept of a track could be found in various models. And as such, to identify how we move forward in a unified manner, we needed to identify where how they were related, whether some of these concepts are parts are different facets of the same concept, or whether some are more specialized than others. And as such, this combined vision of an encyclopedia and a tool led us to okay, so that was my question. So we are still on this. Okay, sorry, I apparently. Okay, sorry for that. So was my question before. So yes, sorry, thank you, Anna. Yes, so ultimately this view of requiring an encyclopedia and a tool for consensus led to the creation of the OntoRail web application itself, which can be seen as a knowledge engine in the sense that it's both a repository of railway knowledge as well as a set of tools powered by ontologies to facilitate and promote the convergence between models. So ontologies, what they are in this particular context of OntoRail, they can be seen as essentially a formal representation of a given domain of knowledge. For in our case, the railway domain, and so one of the prominent factor of ontologies is that within a given domain of knowledge, we identify atomic concepts. And then we need to, those concepts are related to each other due to the nature of the interaction. And ontologies use a precise vocabulary to qualify the relation between those concepts, so that we have ultimately a network of concepts related by the relations, and with indeed a precise vocabulary to link them. And two common understanding of or common representations of ontology would be the example of taxonomies of species in the natural domain, where we can classify here a wolf into either increasing larger body of species. And so the particularity of taxonomies is that they are classifying each subject according to hierarchical organization between parent and child, or between containers and containing. But we have also familiar and other types of ontologies, such as thesaurus, where we extend to other types of relations between concepts. And in the particular case of OntoRail, and for the issue at hand, which is to relate models of the railway domain to each other, when we look at two models, we may identify that something looks to be reasonably similar to something else in a different model, and that would translate into ontology representation, as that we identified that there is a related match between the two domains. And with increasing understanding between domain experts as part of a governance process, and that would allow to build consensus, the domain experts would be able to narrow down the relationship between concepts to eventually realize that for some of the concepts between two models represent the same thing in certain occasions, or sometimes they are two subparts of a greater concept, and that could translate into changes to or into an impact on the common data model. So now, if we come back to the question of how we apply that to the railway domain, So what OntoRail does is to take various models. Here I have listed a few that have been considered so far, but there is even more, as we'll see later this afternoon, on the part where we apply the OntoRail knowledge engine to the links for rail conceptual data model work. So we take different types of model that may be in different forms, such as models like RSM and Eulynx, for example, appear as UML models, whereas in the specific case of the RINF model, it's natively in ontology format. And so we take all these models, we translate them into ontology form to load them onto the OntoRail knowledge graph database. And so as such, at the end of this first step, we have individual models loaded in ontology form inside the knowledge graph. And then the further steps that we need to take to actually achieve a convergence between those models is to start to establish linking between those various models, or more precisely, between concepts of these various models. And the crux of the use of ontology being that we use a formal knowledge, a formal vocabulary to establish these relationships. The formality comes from the fact that domain experts that discuss with each other need to have a precise understanding of how they are actually relating concepts between each other, but it also has an impact on the use of the computer, because if we apply in a computer form this precise meaning to the relationship between concepts, then that means we can process through machines this resulting network of models related between themselves through precise relations. So it's really about establishing consensus and unequivocal consensus between domain experts, but also to put that consensus into a machine readable and machine processable form that we can further exploit down the road. An important aspect as well to be considered as for the OntoRail vision is that we are trying to constitute an encyclopedia of the railway domain knowledge. But obviously, railways are part of a greater ecosystem. They are a form of public transport, and as such, through the OntoRail platform, we can also establish linking notably within the railway domain, but also to domains that would belong to the public transport. One of the prominent ones being the transmodel Seine model. And also, if we take a look at the even greater perspectives, there are relations between the railway domain and the public transport domain with economic consideration, but also environmental consideration. And through the power of ontologies, we are essentially we are flattening the representation of knowledge, knowing that if we have ontology forms of the various domains we're trying to link, we can use the common scheme to actually relate them between each other. So that's the linking part, knowing that once we are, and it's an iterative process of determining relationships inside the various constituents of the railway domains, but also to the other domains. So once we have this combined knowledge about the railway domain, we can start making something useful out of it. And in practice, for the railway digital modeling ecosystem, that means we can try and pick out the relevant part of the models that would be needed for particular projects. So that can be done through filtering of the ontologies, and ultimately this would result in a filtered conceptual model for railway projects to use. And it should also be noted that as part of the ontology stack of protocols that can be used, we can also offer federation and automated federation through computer means with other domains through querying processes. So now if we go more into practicals, so what does the OntoRail application needs to do to realize that vision? It needs to provide a means to import models. So that part at the moment is done through the backend. So we take various forms of model, either extracted from UML models that are in various modeling tools like Enterprise Architect or other, also directly in ontology form, and we import them into the OntoRail application. And then there's two additional main functions that are taking place then is to be able to navigate what has been imported and to also establish relationships between those models. So what does it look like in practice, the OntoRail application? So it's a web application. You will see the URL at the bottom of the page, but it will be also be part of the slide, so you can see for yourself later. And so this web application has two main functions: the view of the imported source ontologies. Here we see Eulynx, IFC Rail, RSM 1.2, the RARINF ontology, as well as two versions of the trans model. And the second function being the establishment of relationship between entities of those imported models. So for the first part, we have a high-level view of the volumetry of what has been imported that gives us an insight as to the complexity and potential richness to tap from in terms of a source of modeling to leverage in railway projects. And it's also providing links to the official home pages of each of these respective projects, so that interested parties can see for themselves more information about these important projects. But the main goal being that here we import those models to consolidate into the graph database the railway knowledge, and then we can use that consolidated railway knowledge to start establishing relations. So when we look at the interface that has been built by our developer Didier Guillonnet, that's been even extensive work on this web application. If we give a unified interface across the source models that we've imported. So regardless of the way it came into OntoRail, it can be seen through a unified interface that presents various level of information. So it represents the structure in a tree view of the imported model. So UML models are typically packaged into package and sub-packages that may contain individual classes, and as such we can through this tool for people that, especially for the sources that have done the UML models, they can see from this interface that the importation has been faithful to the original model. And we also have an overview of lots of properties of the concept within the model that we are looking at, including also its relationship to other parts of the models with the notion of domain and ranges. So we can have a first and very quick glance as to how they relate to other parts of the model. We also have access to the documentation if it's exposed by the source model, which makes it for a quite convenient way to explore those various source models, again using this unified interface. Additionally, because those imported source models might actually be used in certain cases, we have very convenient search functionalities that we'll explore a bit further through this presentation. So this search is a dynamic filtering through the model constituents, including classes and properties, support for the technically inclined regular expressions, which makes it quite an expressive way of going through models. And so we obviously present only the relevant parts of the model that would be a match for this search, which is definitely a very handy tool for quick insights into contents of model, knowing that this can be further exploited when you're looking at multiple models in parallel, as we will demonstrate this afternoon as part of the use case of OntoRail knowledge engine within the Lynx4Rail conceptual data model work and dictionary. Another vision or another visualization rather that we give over imported source model is a graph view. As I mentioned, now we are representing those models in ontology form, which means that we have relations that are concepts that are interlinked with each other from with specific relations that we see through this set of bubbles linked by edges. And interestingly, here we can see both how a given concept within a model relates to other part of its own family, I would say, within the original source model, but also as depicted on this page, its relation to other models that would have been with whom the linking tools that will go a bit later, so we can record relations between concepts coming from heterogeneous models, and as such, through this graph view, we can also see the relationship between two different models, as exemplified here between RSM notion of a junction entity and the IFC Rail turnout panel concept. And we also qualify, as you see, it's here it states it's a related match between those two. So we see objects in context of their model, but also in context of their relation to other models as well. Another important function that we identified we needed to support from the inception is the ability to support within OntoRail knowledge graph multiple versions of a given model. Here we show the example of the trans model as used by the SNAP project as compared to the latest version available on the trans model website, which is version 6.56, and both versions of the model coexist in the knowledge graph. And why do we want to do that? First, because so models are living beings, I would say, or living entities. They are independent initiatives would want to probably explore and expand the coverage of what the domain they are trying to cover. And in the context of linking models together from various initiatives, it's quite important to be able to accompany the life cycle of these models, to be able to take into account additions to that would have been brought to individual models, and also to just for the sake of comparing to the evolution between two versions of the same model. So it's really quite powerful functionality. And now, if we come to the notion of establishing relationships, so we establish relationship between two entities. They are usually between two different models. So here we see the establishment of a relationship between the notion of a root body in the Eulynx data model and the notion of a root body in RSM 1.2. And we can qualify through a formal vocabulary the relationship between those two. So this vocabulary is a formal vocabulary that is unequivocal for both domain experts, but also for computers. And here in practice, we see that we have there's various ontologies that that actually qualify relationships between related ontologies for ontology matching, such as the W3C SCOS vocabulary. But an additional thing that we identified as part of the OntoRail project is that there might be a need to create new terms specific to this matching of models. And so as such, we are developing a vocabulary of linking as part of the OntoRail project to reflect specific relationships between entities. So once we know what we want to link, we can also document what we want in a free-form manner, some document as to how they relate with each other. We also would record who's the initiator of this proposed relation, the timestamp of this proposal, as well as a status. So the status would be here under review, as in it's a proposed relation, but it could also happen that domain experts would already agree that the identified relationship might be stable and definitive, and as such, it could be accepted status. And last things to be noted is that so these relationships between entities across models would be stored inside the knowledge graph, but we also recognize that as part of building a consensus, there would probably be a need to establish a forum where domain experts would discuss and potentially provide pros and counter arguments as to the nature of the relationship, and as such, we would link the OntoRail web application to an external forum to support that process of building a consensus. And last but not least, once we created something, we still need to see it. And so here we have also functionalities that allows us to see the latest proposals that have been submitted using the tool. We have various metadata available, such as who's proposing it, when, and comments, for example, that would be available. And we also have various convenience functions to manage this set of relationships. So all in all, as we will see more this afternoon for the application of the OntoRail knowledge engine to the Lynx4Rail common dictionary and its relationship with the common the conceptual data model. We are so the OntoRail web application is still under development, but it's now reaching a quite satisfactory level of functionalities and maturity, whereby it does indeed provide a consolidated view over in a unified manner across the various initiatives existing in the railway domain for modeling of various parts of the subsystem. And further, through the use of this linking, it's no longer isolated silo of digital models, but they are slowly becoming or will slowly become when relationships will be established by domain experts and will be agreed upon by a domain expert between those models. We are will be building an encyclopedia of railway system modeling knowledge. It's not a knowledge that would be closed on itself and only looking at the railways, but it's also open to the greater world of public transport, but also the entire society. And all of that being backed by the power of ontologies. and naturally to get there, tools were required to facilitate this convergence of model, and as such, although the domain of vocabulary of relationships is still in building, but there is already quite a number of elements of vocabulary, a formal vocabulary that can be used to build the consensus that's made available for domain experts seeking to establish a consensus between models. So as mentioned by Eri at the end of this presentation, this would be the time where we open up the floor for questions. I'm not sure whether there's been any on the chat. If somebody has checked. So I see. I see at the moment. I see one question. So from Bob Janssen from Eulynx. Hello, Bob. What happens to relation when you update and import of the model? So the relation that would have been established with a given version of the model would be retained. The question that might be a follow-up to your question, Bob, is as to whether we would naturally port it to the or extend it to the new version of the model. I guess that would be something that would need to be looked at as part of the governance process, because in certain cases we could naturally think that the relation would be extended to the new version of the model, but maybe it's not applicable in all cases. I see another question from Nadia Shushani. Is versioning dealt with at the level of the DBMS or the conceptual model itself? I didn't see the question from Billy. Can you scroll up? If you scroll too fast. Indeed, but BSDD is so just one point that indeed Alain pointed out that we will provide a link to the GitLab at the end of the presentation. Second thing is I saw a question from Marine. I didn't catch the name, but no, not Marina Aguado, but I see a Marine that was asking whether we would share the presentation. Indeed, it would be at the end of the a couple of days after the workshop, the webinar, we would share the presentation, and with allowed to have access to OntoRail. So the idea of the OntoRail web application is for it to be open for people to use it. We have started building logins, login system to facilitate control of who has access to it, and ultimately it's intended to be also an open source application. So at some point in time, it's not there yet, but we would intend to publish the source code, and so indeed it could be used for education purposes. I see another question from Ramesh Babu. How do you instantiate a project with the combined models and ensure that the correct relations are used? Is there a validation tool for the instantiated project model?
For that purpose, we intend to use open source validation. That is checkers that check the correctness and completeness of ontologies. So these open source tool sets that are, for instance, already used in Protégé, for instance, are also meant to be installed in OntoRail as an internal control tool. but it will require some additional development. For the time being, we are more into the display, import and display. Please remember that many ontologies are imported, in fact, extracted from UML models. And this by itself is already a challenge because there is no standard tool for importing UML into ontologies. So we had to design them, keeping in mind the purpose, which is round tripping ultimately. That is, it's not just about imaging the concepts that are enshrined in the UML models. It is also about being able to regenerate models from the ontology. So there is some additional vocabularies to be defined here because some concepts exist in UML that are not pre-existing in ontologies. So we have to be a bit careful. So once again, this tooling part will come as a second step, especially when we get to the model generation. So this is a work in progress because this is exactly one of the aims of the Links for Rail project in Shift2Rail, to which UIC participates. Here OntoRail is, I would say, the essential part of so-called work package 2. And work package 3 is about being able to generate UML models for further usage, like code generation, serialization, etc. And it seems that the best way would be to start from the ontology level. So, of course, if the ontology is not consistent or not complete, we may have difficulties in getting useful UML models. Worse, since the purpose is to say, well, ontologies are huge. I mean, the RSM plus Eulynx, etc. Users will want to select a subset and make it run as code or schemes. So we must make sure that the selection that is achieved by the user will be itself correct as an ontology in order to have a chance to generate a correct UML model. So indeed, you touched a very sensitive zone. For the time being, we are about prototyping. I hope in a reasonable amount of time, we'll get also to the full industrialization, including checking. I see also Christian Weber asking again, why is TAF-TAP not mentioned, neither in my presentation about RailSystemModel nor about in the OntoRail presentation? Well, the general answer is we are ready to use any existing model as soon as it is available and publicly available, and we are allowed to. So here it's totally an open field. For the time being, we are not much into operations, I would say, because we are focusing for the time being, especially for RSM, on the network parts and then rolling stock and operations in upper layer. So in terms of chronology, we were not we are a bit slow at embracing that part of the world, I would say, the operational world and the commercial world. But this is definitely envisaged for the next steps, knowing that it's also one of the subjects discussed in the Links for Rail project by Shift2Rail. That is, what candidate models should be taken into account or not for the so-called common data model. This is a subject for this afternoon, by the way, so we'll get to discuss it more into detail this afternoon if you like. But here we're at the service of the industry to some extent, and although, as I said, we are ready technically, especially ready to assemble any further public model or ontology, because we have prepared the technical field for doing that in an elegant way. On the other hand, what the priorities are is for the industry to decide, and UIC is one participant here. It's not the institution who says we shall do this and we shall do that. So once again, totally open. TUFTAP data model is one thing. The RINF data model is another thing, etc., etc. Here you could. It's a very long list, in fact. So once again, there is no ostracism if that was your fear regarding TUFTAP. Just I would say the contrary. One of the important things is I think that the START, the so-called START project, initiated by Shift2Rail a couple of years ago, around 2017, was itself based on TUFTAP. Maybe I'm wrong here, but if that's the case, they have an ontology ready that could also be reused. So I expect also the START ontology to be mentioned by different participants.
Thank you, Eri. And just to reinforce what Eri said about the openness, I think one of the key principles here is that having we know there's lots of modeling initiatives available. Some of them have been listed and have been identified, notably because they are already either they were there at the beginning of the project, or also because they are being considered as part of ongoing projects or collaborations that we have around the OntoRail web application, as well as RSM. Ultimately, what we see is that there is a rich ecosystem of modeling initiatives, and being able to link them, I guess, to a certain extent, the more the merrier. Obviously, we have limited time, nevertheless, as anybody else. But for sure, it's the value is in the accrued knowledge of the railway digital modeling ecosystem. So, and the openness also to the external models, regardless of whether it's directly in the railway domain, is also a key constituent of this vision. So. Now, looking at the time, and again, I'd like to reiterate our apologies for the glitches, more than glitches of the beginning of this webinar. Just to say a few words, so we'll restart for the second session of the afternoon at 1:30. We'll probably keep the Zoom meeting open to prevent the technical issues to reappear at the beginning of the second session. So hopefully that will facilitate the start of the second session. And so in the afternoon, just to give you a taste of the program, so we'll look at the application of the RailSystemModel and OntoRail as part of the Links4Rail common data model building. We'll have also a presentation of digital twin initiatives at SNCF by Gilles Dessignes, SNCF Réseau. We'll also have an introduction to how we could foresee to use a RailSystemModel in support of the UIC FRMCS project. And just for people that might not be aware, FRMCS is the Future Rail Mobile Communication System, the successor of the GSMR mobile communication system for railways. And we also have an intervention, a talk by Mr. Bob Jansen from the Eulynx with the information modeler for Eulynx, and then we'll expose the next steps, or where we see RSM and OntoRail going in the future. So again, thanks for your attention thus far. Sorry again for the glitches, and we're looking forward to continue at 1:30 this afternoon. And until then, we wish you good appetite. And if you have questions that you would like to ask, because we'll leave it open, you please use the chat for that purpose, and we'll look at them during our lunch break. Thanks a lot, and see you this afternoon. Thanks. So, this afternoon we're gonna, as briefly mentioned before the break, we will go through various perspectives on the subject of digital modeling, and we'll start right now with the usage of RailSystemModel and OntoRail as enablers of the Eulynx4Rail conceptual data model. So what is Eulynx4Rail? So Eulynx4Rail is a Shift2Rail project. So Shift2Rail is a European research program funded by the European Commission as part of the Horizon 2020 program. And so within Eulynx4Rail, Eulynx4Rail is a program that identified that there was fragmentation in the railway sector across subsystems. You don't see my screen. Okay, thank you, Alain. Maybe now you see it. Thank you, Alain. Sorry, yes. So fragmentation in the railway system, and what was missing was a way to integrate and make this system to interplay as a one common ecosystem. So Eulynx4Rail was kicked off as a project somewhere in December 2019, and as you see on the right hand side of the screen, there is the programs, the landscape that they identified as being relevant for this integration of various modeling initiatives into the conceptual data model. And as you see, these are amongst others IFC Rail, which is dealing as a specialist project for building information modeling as part of the work of Building Smart International, the Eulynx project that was looking at standardizing interfaces and elements for the signaling. There was a domain of rail operation, where you see here RTM, the former name of RSM, as well as RailML, and also relationship with the RCA reference CCS architecture. And the outcome of this discussion was to actually create, to structure the project of Eulynx4Rail across the 5 work packages. One of management, WP1. The WP2 was tasked with defining a common data dictionary around the ontologies. There was work package 3 leading the work to define the conceptual data model of Eulynx4Rail. Work package 4 was looking at using the CDM, exploiting the CDM with respect to particular use cases, several of them, traffic management, and a few other use cases. And finally, a work around architecture, which is work package 5. And so within the context of Eulynx4Rail, as you would have guessed from the introduction to OntoRail that was done this morning in this morning's session, there is a natural fit for the use of the OntoRail knowledge engine for Eulynx4Rail purposes as part of the work package 2, which is the definition of the common data dictionary. And obviously, there is a linkage between the common data dictionary and the CDM that is also a point of interface between work package 2 and work package 3 within Eulynx4Rail. And finally, as we'll go through in a bit more details later, there is also a natural connection to the work package 4 work, because work package 4 needs to identify objects that can be used for fulfillment of various railway use cases, and the ability to look and search across the various federated model is indeed a useful feature. So in practice, this looks very much like what we saw this morning. So within the current work of Eulynx4Rail conceptual data model within work package 2, the OntoRail knowledge engine is importing both RSM, Eulynx, IFC Rail, the RINF, and also should be noted that was not on the part of the presentation this morning, the X2L4 model, I believe it's mainly around timetabling, but there might be other features of the models that were deemed useful for integration. But so this would be the various models that have been considered, and more recently there were requests to consider as well the transmodel model, and so that's why you saw it featured on the OntoRail web application homepage. So at the moment, these various models, as described this morning, are imported into the OntoRail application. In their current versions, there was actually, because as we were indicating, there were evolution of these models. It's a natural life of models to evolve, and as such, the importing has followed the life of those various projects to and the architectures that have been put in place by the OntoRail application has proved to be resilient to these changes. Now, as part of the work that is being done, there is quite a lot of interaction with the leaders and the participants of work package 3 within Eulynx, which builds a conceptual data model, notably because one of the key aspects that needs to be solved as part of the federation as model is to determine how to resolve and how to address overlaps or relationships between models, and so the other aspect is how to build this a process that would allow us to go through these relationships and to properly qualify them. And so the work on the conceptual data model is still ongoing, but at the moment we've been able to demonstrate in a series of workshops the functionalities brought by the OntoRail knowledge engine to the problem, and these are the web application is made available to Eulynx members so that they can actually start doing this work of integrating models with each other. At the same time, the OntoRail web application, thanks to these various imports, is also available to work package for members of the Eulynx initiative, so that they can browse through the source models to identify suitable objects for their own use case, knowing that ultimately it's up to the task for work package 4 to leverage directly the conceptual data model as part of the final process. So, so now if we look into broad stroke, what we bring in terms of functionalities as part of the Eulynx work. So there is consolidation of the railway domain knowledge. So as indicated, we have so far 5 models, actually 6, that would be consolidated eventually into OntoRail. So that's a part of gathering available railway knowledge, put it into a unified form into one knowledge engine, and then what comes after is annotation. Annotation is about establishing relationship between concepts within those models, and to make sure that the relations that are established between concepts are actually unequivocal meaning for all participants, so that we can proceed to the next step, which is the federation. The federation is to take all these relationships and makes common sense of these relationships to build a common conceptual data model that takes the relevant part of each individual modeling sources, and also recognizes that sometimes some concepts in available models might be more extensively described or more appropriately described in a different model. which could lead to the need to supersede one by the other as part of the conceptual data model, but ultimately as part of the convergent process. There's also a phase that could take place, which is a phase of feedback loop into the source models, which is both a matter of evolution and a matter of expansion. So to take the latter, expansion is to identify that maybe as part of the specific use cases that need to be tackled, there might be a need to fetch new sources of information, new sources of knowledge, and transmodel is one such example. And as such, expand the list of Lynx4Rail source models that should be considered for the building of the conceptual data model. Evolution is actually a bit more tricky because here it's both recognizing potentially that different models that were developed independently have commonalities that they might want to exploit to build upon one another. Could be also to document, or rather to tag specific sources, a specific concept in the individual sources to reflect what has been learned as part of the annotation and federation process. That being said, all this work is not taking place by itself. And so if we drill down in terms of what the consolidation entails, so first, for consolidation to happen of a model, it's very important to have the model available in a form that can be used for import. So at the moment, we're mainly importing models that come in a UML description, but also in the case of RINS, it does appear as an ontology form. Second thing that's important in the context of trying to build a common data model is to have adequate licensing terms that would allow the federation of those models together, because they need obviously to be compatible from that perspective. And then once we are able indeed to proceed with the import, the question is, if we import something that was not natively in ontology form, is the result of this import representative of what we started from? And as such, there is a work of validation with source projects owner that is required to guarantee the faithfulness of the importation. And as such, that's where the process of import is both a technical process of being able to process source model in their source format, but also to make sure that there is no loss of information as part of this process. Second thing that's very important to consider that the consolidation, and that was highlighted in this morning during the session, is the ability to support multiple versions, because for all the models that are being listed in the source model on this slide, they are evolving over time because they address new domains, new subdomains. They are trying to model as part of the response to particular use case, as was demonstrated, for example, by Eri this morning with the evolution of RSM, which expanded amongst other things for the modeling of the energy, for example, and so the environment such as the weather. So it could be expansion. It could also be evolution of the domains that were already modeling by having a further specialization of some of the classes, or taking into consideration new properties and things like this. And as such, it's very important to be able to support multiple versions. And knowing that the practical impact in the end, when we look at the federated model, is if we have established links from one given model to another model, what happens to that relationship that has been established once the model evolves? And that will be obviously a very important thing to consider as part of the federation process to be able to have a sustainable and ensure the digital continuity of this federation of the various models. So second step at the annotation. So as we said, there is a need, and that requires involvement of domain experts. There is a need to look through those various models to identify and qualify the relationship that those various models may have at the concept level. It requires expertise because it's not because something has the same name in both models that they are the same thing. As we mentioned before, those various digital modeling initiatives, they are looking at modeling the system from sometimes different angles. They are not looking at the same life cycle of the railway project, and as such, it's really a work of collaboration that is required to be able to qualify a relationship between concepts. And once some form of relationship has been established as being required, it needs to be properly qualified, and that's where the use of the ontologies to give precise meaning to the relationship between concepts is quite important. I'm not sure whether there's any question on the fly. Just to let me know if there is. Okay. So just at the first step, the federation. So as we indicated, so we need to build consensus. So we define that there is a relationship, and we know it moves forward, that allows us to contribute to the building of the CDM. But another thing that that comes as a result is that we might identify specific modeling recommendations that would need to be reflected or to be passed on to the original source modelers to facilitate first the federation process, and there the facilitation can come with in the form of, for example, tagging of specific information that would capture inside the respective models the relationship between them. It could also take the form of more general modeling guidelines that could be put into play. And in the fourth step, if we have identified that we have a need for new domains or new object, in the same way that if we identify that, for example, two classes would be let's say two facets of the same thing, it might result in a change in a more generalist model, for example, such as RSM, to actually capture this ternary relationship between concepts. So it's really the OntoRail knowledge engine comes as a platform to facilitate the convergence of the federation models. It can allow to make emerge, I guess, those relationship, and then it's up to each of the sources, and it's part of the governance process to make sure to put the necessary actions to actually prolong into the models this notion of convergence and of federation. And knowing that it remains obviously quite important to each individual source owner to remain independent in its evolution, to the extent that you don't want to be, let's say, dragged down or slowed down by collaboration, but you still want to be aware and take into account what other modeling initiatives are doing in order to have an efficient ecosystem that can slowly evolve to a form of convergence. Now, if we look at it from a more details as to what it entails for during the work of Links for Rail. So we are in the following few slides. We are actually taking a user story orientation, which is that we have imported a model, as mentioned briefly this morning. The question is, did we import, or did we represent faithfully what we have imported? So here we are taking the particular case of RSM, where so it's originally a UML model captured in enterprise architect. So it's been exported as an XMI and imported into OntoRail. So we have the representation of the package and subpackages of RSM that appear in the T browser, and we can compare, or we can have a graph view of how what has been the concept that have been imported relate to other parts of the model, knowing that the individual models are although they're organized in package, there might be relationship between package, which essentially makes it a graph anyway. But through the visualization tool that we provide with the OntoRail knowledge engine, we can get some form of confidence that indeed there has been no loss of information in terms of the importing process. Now, if we look at the angle of, let's say, for example, the work package 4, what they are looking at is to fulfill the needs of particular use case, whether that's traffic management, whether that's predictive maintenance, whether that's any other railway use cases that would be foreseen. And the question is how to actually, without having a first or exhaustive understanding of all these source models, how do we figure out what's available already to actually fulfill those needs of particular projects? And as such, here, through the use of the visualization capabilities of individual models, we can launch separate visualization of various sources in parallel, and use the search capabilities to identify the relevant objects that could be used to build a particular project. As such, as we indicate on the slide, it's important to not be too surprised about the fact that some classes may appear in multiple places, because ultimately it's a nature of this of the building of these models that there is relationships between classes that might not belong to similar packages as part of the modeling process. That being said, the ability to do this search across model and being able to check as well the context of usage of these particular classes belonging to different models within their own modeling environments, and also the ability to figure out the relationship potentially to other source model if some has been recorded in the knowledge engine as part of a collaboration, is a very useful tool to get a much quicker insight into what's richness you can tap from source models. And that's something that if we were just to have access to let's say UML models as published but entirely separately, it would be much more difficult and much lengthier process to actually be able to make that inference of relationship between the models this way. So we are providing here both a powerful visualization as well as exploration tool for users of models. Now, if we come back to the question that was intended for the conceptual data model, which is the willingness to establish candidate links between models. as described this morning for the general description of OntoRail. The OntoRail application allows domain expert to search for relevant classes to be linked between two models. So you identify that there is something that, so here we show multiple cases of relationship between the RSM model and the IFC Rail, as we see. So if we were to look for dilatation panel, we would identify that there is two such classes in each of the models. The visualization tool would allow us to determine whether they are indeed or their level of relationship. Obviously, one important thing to consider as well is that at the beginning of the process of trying to assert candidates links between concepts, the person doing the investigation may not have definitive view on the relationship, so it might just come to the point and says that there is some form of relation, as indicated by the related match as part of the Scots vocabulary. That being said, we could be in other situations where there is, for example, pre-existing collaboration between two source models. As Eri mentioned briefly this morning, there is collaboration, for example, between the RSM and Eulynx modeling, and in certain for certain classes they mirror each other, as in some borrows a class from the other UML model, and as such they have done the respective models have done the necessary work of documenting this relationship in their model. But ultimately the tools that are provided allow to qualify in a more or less precise manner, depending on how much information has been gathered at that time, to qualify the relationship and to start the process of doing this convergence between models. And now, if we if we take it from the next step, is it that we have started to establish that there might be a relationship. So it's annotated with relevant metadata who has proposed. It could be some specific roles related to the governance process that could also do that. It could be an account associated to a group of experts as well. It could be anything, essentially. We provide additional metadata that we attach to this proposal of a relationship. And then what we anticipate would take place is indeed that for cases where it's not entirely obvious, there would need to establish a discussion between stakeholders. And as part of this discussion, there would be probably a need to exchange some additional contextual data as to why people may have diverging views on the nature of this relationship. And as such, as mentioned this morning, we saw that as being a separate set of functionalities that what was being envisioned for the OntoRail knowledge engine itself. As such, we intend to piggyback on functionalities available in the software development world to foster this kind of discussion. For example, using functionalities, forum functionalities of sites like GitHub, GitLab, or others for that purpose. That being said, at some point in time, consensus could be reached between stakeholders as to whether given relation is accepted or rejected. And then, as mentioned prior, a discussion may then entail. As a result of this discussion, it could lead to action on the source models to enforce or recognize or to document the relationship that has been established between models. The reason why you might want to do that is that it obviously increases the level of knowledge that each model has between each other, and it ultimately facilitates further federation, especially for further future versions. Could also lead to the creation of new parts of models that will recognize the relationship between the different models. And also it could be one of the results could be that, well, maybe the link that was proposed was not the right one, but maybe it could lead to the creation of other proposals that would better reflect the relationship between those models. So here what we show on the right hand side of the screen is a case where we look at the notion of a root body within RSM, and we identified that there might be a relationship to be evaluated with the concept of a route in the trans model itself. And so through the tools that we have presented, we should be able to facilitate that that discussion to establish the nature of the candidate relationship and potentially to recognize its nature. So at this point in time, before we move to our next speaker, is there any question from the audience? None at this stage? Okay. So I think I've seen Gilles connected.
Yes, I'm here. Hello, Pierre.
Hello, Gilles. Thanks for joining us.
I try to share my screen.
Yes, normally you should be able to. Otherwise, tell me if not. I will stop the sharing on my side. Maybe that will help.
Do you see my screen?
Yes, I see it, yes.
Do you see the presentation part?
Indeed, indeed.
It's okay?
Yeah, it's okay, Gilles, you can go ahead, thanks.
Okay, thank you. Hello to everyone. Thank you for having me here today to share our experience on the digital twin and its application in the field of traffic operation. You will see it's a point of view of enterprise architect, and we need to work on this a lot today and tomorrow. To begin, just a small introduction. Today, SNCF Réseau faces four major challenge. The first is it to assert its identity at the hub of the railway system. This is very important to meet the expectation of our current and future customer and partner. It's very important for us. We must also to ensure the safety and performance of the network, renovate and modernize the network, and develop the network of the future. All of this must be done, of course, while controlling our economic trajectory and our advancement too. The digital twin, it's very important for us, for all. And today it's a very big performance lever for SNCF Réseau and for all players at the enterprise. To implement this breakthrough with your colleague, we began by sharing a common definition within the company of the digital twin that it is and that it allows us to do differently. I present it to you on this slide just to share our vision. The digital twin is a digital representation of the railway system in all its dimensions. It's make available to everyone information of description, the state and dynamic of the network, the usage, the works, the operation, traffic operation, and the resource and finance of the railway system. For us, the digital twin covers the entire life cycle of the system in its historical, current, and future view. This shared information and all the associated services define for us the digital twin. And tomorrow and today, this digital twin offers to us unique vision of the system and, for example, elaborated function such as calculation of path, running time calculation, prediction for the maintenance, and robustness of the traffic. A little note to Alain for this diagram. I reuse it because I think it's very clear to understand the digital twin between all the processes of the system. So our objective for all our business is to share a common digital twin of the railway system to digitalize their processes. From the need on the left to the end of life cycle of installation through engineering, implementation, operation, maintenance, operation, and so on. To realize this digital twin, we needed to define a common model in a systemic approach. Just for the story, we started in 2011 with the description of the network and the traffic. Since then, while collaborating with RTM and RSM now, another model, standardization, we have enriched our model for each subsystem. Today, the notion of a common digital model has become a matter of course in the construction of the digital twin and the digitization of processes, as well as a company data governance approach. Today, it's very important for all my colleagues to define a model before to work. Little joke in the title of this slide. Just for us today, after different sharing with my colleagues, the information system and the digital twin are one and the same for us. It's very important for us that the digital twin is not a new part of the information system. It's in the continuity of the actual system information, but with another approach, another systemic approach. Without going into detail, the construction of the information system is broken down into 4 layers according to the classic principle of IS architecture. In the business layer, we work with our business to define concept, ontology, glossary, business object, and process, like that explained before by Pierre. And a second layer, the functional part. We found our common Ariane model. Our common model is named Ariane at SNCF Réseau, like RSM, which allow us to constitute the digital twin. The other two layers concern the implementation and the technology of the information system. As for the construction of a house on the right, the blueprint of the house corresponds to the common model of our digital twin. It's just an image. It's very important in the construction of the system information that it's driven by a modeling approach. Today, for us, the common digital model is at the heart of the construction of the information system for all of new development. Just to summarize the approach, we therefore need a common systemic model at the top of the slide. Today at SNCF Réseau, it represents average 2,000 of classes, which we instantiate in data repository accessible by services. We complete this numerical representation of the entity of the system by function, also accessible by service too, which materialize the elementary activity of the processes. And the middle part of the slide represents the instantiation of the digital twin. Of course, the digital twin is then connected to the real world, to command, control, supervise, manage, and maintain the railway system. So as you can see, the common digital model is a blueprint of digital twin. Thus, each services for the entity, for the system, and for its function expose data respecting the common model in XML, JSON, or other if need, and it's the same at an implementation of RSM or IFC or another model. I try to respect the time. Just to finish, just a little focus on traffic operation. Today at SNCF Réseau, we work at the beginning on the story you see before. We work on the operation part of the system at first. And we work on the definition of the model of the traffic, running path and management system, and on the rolling stone, on the capacity for works, on the model on the network at first, and of common model of network state, the dynamic state of the network to manage the traffic. This allows us to simplify a complex vision of the system, to bring fluidity to the process, to obtain more precise feedback, and consider new strategy. Today, some of parts are completely implemented in an IT system, and today we work to construct the rest of the digital twin subsystem by subsystem. Yes, and of course, our digital twin is not finished yet at SNCF Réseau. In a few words, this is how the digital twin is shaping up the world of operation. Thank you for your attention, and if you have any question, I'm pleased to answer it. Thank you.
Thank you very much, Gilles. Is there any question from the audience?
No question, Pierre?
No, apparently no, not from the audience.
Okay, but I stop the sharing.
Yes, we have a raised hand. I see Peter Axelsson. I think you can unmute yourself. Go ahead, Peter.
Thank you. You hear me?
Yes.
Yes.
Thank you. Thank you for a presentation here. It's Peter Axelsson from Trafikverket in Sweden. And I have some questions regarding your definition here of a digital twin.
Yes.
Where you say that it's more or less the same as all of the information you have of the railway system, which is maybe a little bit different, even though there are no clear definition of a digital twin. I think maybe it's a little bit different than many other definitions of a digital twin. How did you arrive to this? Do you think, is it meaningful to say that it's all of the information? Then it's nothing else than your, as you say, it's the same concept as your information system.
Perhaps I'm not clear in my definition. Sorry.
If you go back to
information. It's information, but it's information of numerical entity of the system. For us, in your repository, you obtain the numerical representation of the entity, track, train, and so on. And this numeric representation on the different facets, description, dynamic, representation, first dimension representation, and so on, materialize the digital twin. And to finish a digital twin, we digitalize the common function of the system.
But do you see it as that you have one digital twin or several digital twins for your system?
Okay, good question. At the end, we will have a unique digital twin with a lot of facets of the system, because we base the construction of digital twin on the same common model, and each subsystem are modelized in the same systemic approach. Modelize each part of the system, and step by step we digitalize the system, subsystem by subsystem.
Yes. Do you see the visualization as an important part of the digital twin?
Yes, because it's a very important manner to see it and to challenge it, to test it, to view it. And the second dimension or third dimension representation of the system, or another type of representation, it's very important to manage the digital twin and to test in, to check in, and to use it in all process of the system. But it's just a part of digital twin. Is not the digital twin. Is not just a digital twin, the representation, but it's a very part of this.
Okay. Thank you.
Thank you.
Thank you. I think we have another question from. So we have a question from Marin that asks you, what sensor do you use to capture data?
Sorry, can you repeat, Pierre?
What sensors do you use to capture data? That's a question.
We have many type of sensor to capture data. In digital twin at SNCF Réseau, we not just consider the sensor for example for the position of train, for the temperature of track, or we consider all the part of the system. Today, the sensor perhaps in certain cases are human during the study and conception phases. But in real time, effectively, we use a lot of type of sensor, all sensor, all the technology to capture, for example, the position of switch, or a new sensor to capture the temperature of track, or to measure the sorry, I don't remember, Pierre, comment dit gabarit?
The gauge.
Thank you. The gauge of the track by laser analysis of the context. We use many type of sensor to capture information to supply the digital twin.
I think we have a question from Sanction Zhao from Karsh. You mentioned RSM was used in your digital twin project. Could you please explain how it's used?
Good question. RSM for us is in the standard model of railway system. In first, we use it to challenge your approach to build your own model, naming Ariane at SNCF Réseau. But we use it to share information with another partner of client, a customer, for example.
Thank you, Gilles. We have a question from Marina. A question about your interfaces or data exchange with SNCF Réseau stakeholders.
Today we have many type of interfaces with stakeholder, and the ultimate goal is to use a standard model and format. And today we have many type of model and standard dependent of the maturity of a relation with the stakeholder. I hope in the future all the people use RSM and Eulynx and IFC and so on.
Certainly we do too. Pierre-Etienne is actually just pointing out that there are three main functions in the digital twin: visualization, simulation, prediction. I'm reading on the comment, and the digital twin is supported by the functional model of the network, as you explained, Gilles.
Yes.
Also by a common architecture of the railway system as developed in Links 4L.
Yes, it's the first brick to build the future of railway.
So we have another follow-up question. It's a very popular presentation, Gilles. Thank you.
Yes, sorry.
Marine is asking, is the whole network equipped with monitoring devices, including level crossings and obstacle detection everywhere in the network?
What's the question exactly? Sorry.
Is the whole network equipped with monitoring devices?
Yes.
Including level crossings and obstacle detection everywhere in the network? Les passages et niveaux et la détection d'obstacles à travers le réseau, en fait.
Yes. Today we for all type of this device and control system, we work to use a unified model to capture information on this device. For example, we work a lot on the measurement model to obtain a generic model of measure, and after we specialize it for each type of measure.
Yeah, I think that's the power of the model to be able to indeed
Yes,
unify the presentation you have.
Version of,
Yeah.
yes, yes.
And if I may add, we had a similar experience in the Optima project where weather reporting and weather alarms were a part of the menu, if I may say so, for the traffic management system. And the first step was indeed to integrate such a module into the model, which was briefly presented this morning. Rather uneventful, I would say, modeling step, but of course quite of interest for operations.
Yes. No more question?
I was on mute, sorry. There is still one question after I know you will have to leave us, Gilles, soon, but we have one question from Marina. How do you build federated queries between data expressed in accordance to your different models? So federated.
Sorry, can you repeat the beginning of the question?
How do you build federated queries between data expressed in accordance with your different models?
Today we try to implement this model everywhere on the IT system, but we have a lot of part with that it's the legacy system, and we need to manage the interfaces with the legacy to capture the information produced by the legacy.
If I may, Marina speaking. Hi.
Yes.
Yeah, the question is if you add all the data together in a unique data space in order to query the data coming from the different legacy systems, do you transform it into this Ariane model or not? You keep it in the legacy?
Yes, if it's possible, we transform the legacy information system to the Ariane model. Yes, yes.
And then you query there from all together.
And it's interesting to qualify the data, to check its quality. It's very important to us to have a good systemic view and ensure to when you use the data, it's a correct definition of the data. For example, we have many type of mass of train. It's very important for us to define that it's a type of mass, and it's a good mass for my question, and always it's possible we convert all the data in the new Ariane model. Yes.
Thank you. Thank you.
And we share to the other process after this transformation.
Thank you, Gilles. I think, if I understand correctly, you needed to leave us now.
Okay.
Otherwise, there might be one last question, but I think the answer is no. As to where we can find the Ariane model, I think it's internal to SNCF Réseau and not available for educational purposes, but that's correct, right? I think.
Yes, yes, yes.
Okay. Thanks a lot again for your time, Gilles, and for your presentation.
And sorry, I have to leave you because I have a meeting. I'm
yes,
sorry.
Indeed. You had mentioned it. So thanks again for your participation.
Thanks for you. And see you soon. Bye-bye.
Yes, indeed. Thanks.
Bye-bye.
Bye-bye. So let me take over the screen. Yes. Okay, so now the next subject as part of this webinar is a perspective on how we could make use of RSM in the support of the migration towards FRMCS. So first, one thing to note. So FRMCS, I'm not sure all people in the audience knows, but it's UIC project launched somewhere like in 2012 or something, that's looking at providing a successor to the GSMR mobile communication system that is deployed in many countries in Europe, but also outside of Europe, and using the GSM technologies that first deployments were around the end of the 90s. And it's currently planned to operate until somewhere in the mid-30s. The FRMCS project itself is currently still under specification, but the first deployments are anticipated around 2025 in Europe. And this FRMCS system is built on 5G technology. But if we look specifically at the case of Europe, GSMR networks were actually built according to the performance of the GSM system using the 900 MHz spectrum, which the combination of the constraints, radio constraints of GSM and this spectrum led to the deployment by infrastructure managers across Europe with a certain intersite distance. As part of the harmonization process of spectrum in Europe, at the end of last year, infrastructure managers were awarded the ability to use both reuse their existing 900 MHz spectrum, but also to extend it to use another band of spectrum in the 1900 MHz spectrum, knowing that one of the key challenges that comes into play is that GSMR and FRMCS network are expected to operate at the same time for a period of migration. And one of the key questions related to the migration to FRMCS is that of the reuse of the 900 MHz infrastructure, in the sense that if you can reuse especially masts and existing sites with power transmission and a few other technical items, then you could have massive savings in deployment of FRMCS network as compared to build an entire network based on the new frequency. So now, if we look at this issue from a RSM perspective, what does RSM bring to the table? So, assuming we have a description of a railway infrastructure in RSM form, so one of the key components of RSM is its ability to describe the topology of a network at different level of granularities. But if we combine this understanding of the topology of railway networks with a model of traffic, as in you can have a simulation of circulation of trains on this topology. That means we would have first view as to how many or where trains would be on a given system at any point in time. And as such, if we associate that with a traffic model associated to the communication services that those trains would need to have to and from the ground, this leads to us having a view on the telecom needs projected on the topology, as in overall the topology would need how much uplink and downlink capacity we would need to support the projected traffic models. So once we understand, or once we can evaluate the need, the question is, can we fulfill that need, and especially can we fulfill it with the existing infrastructure that has been deployed? So there's lots of things that come into play into doing this evaluation. One of them is obviously knowing where the radio sites are present over this topology. And as such, there is various constructs that allows to also represent that in a digital model as part of the RSM capabilities. There are other aspects that could borrow from models coming from different sources. One of them being, for example, IFC around figuring out what type of infrastructure telecom tower we would have at a given place, including its structural capabilities. Because when we look at implementing a new system, if we have to bring new antennas on sites, this could have implication whether the telecom tower structure can sustain it, and as such, having a digital representation as well of these assets could be of use. So, if we know where we have emission sites, if we know what type of characteristics they have, such as antennas and heights of the antennas, then we can start entering the interesting question as to what would be the impact of implementing FRMCS on those sites, with the idea that the best outcome would be, oh yes, we could reuse existing infrastructure and do what we need to do for the introduction of FRMCS. And as such, there is another interesting characteristic or modeling capability within the RSM framework, which is the observation and measure package that was introduced as part of RSM 1.2, where infrastructure managers across Europe are operating measurement trains for various purposes. Those measurement trains, they run over the railway infrastructure to qualify deformation of the rail, they can qualify state of the track, they can qualify lots of things, but another thing that they can do that's pertaining to radio is to somehow measure the quality of the signal as received currently from DSMR sites. And once we do that, we can compare what we observe in terms of path loss between known emission sites and the positioning of the measurement train over the infrastructure. We can start comparing it with what we would predict the quality of the signal should be according to some specific models. And as such, the ability to have a model that also takes into consideration the time that allows us to compare observation and prediction is already a key interesting tool to figure out whether when we do a simulation, whether a specific propagation model is more suitable than another one for the purpose of doing a simulation of what we could do with FRMCS. And now that we have a characterization coming from a realistic measurements in the field, we can start inputting that into to modeling, as in simulation tools of radio performance for the FRMCS network, knowing that what we would need to perform in terms of study would be to compare both performance of FRMCS at 900 megahertz, but potentially also FRMCS at 1900 megahertz, knowing that the frequency would have an impact on the bringing new additional propagation loss. And so if we apply those FRMCS radio performance simulation to what we observe from the real world as gathered and represented in RSM so if we play to what we observe, we can start making telecom predictions of what the FRMCS network could offer at under certain conditions at 900 and 1900 megahertz. And this second part of the equation is essentially what would allow us to compare the two. What are the needs as projected on topology? What are the predictions that we could offer? And then the combination of the two allows us to have a first view as to how much we could reuse the 900 megahertz infrastructure, and as such assess the or size the investment that would be required to fulfill a particular scenario in the migration towards FRMCS. I'm not sure is there any questions? I don't see the screen, so I cannot say. So if there's no question, then I think Bob, you are here. So let me, I think I've made you a presenter. So we will move now to the next presentation, which by Bob Janssen, the Eulynx information modeler, on the signaling data preparation with RailSystemModel and Eulynx. Bob, I stop sharing and you can go ahead.
Yes, tell me when I'm on.
So I can hear you.
Yes, you can hear me. That's a good start.
And I don't see your screen yet.
Not yet. Okay, let me, struggling with it. Share. They should be better.
Yes, we can see. Thanks.
Okay, thank you. This talk is about Eulynx data preparation. For those of you who have never heard of Eulynx, I'd strongly suggest you visit our Eulynx EU website, and more in particular, of course, the data prep part of it. For those of you who don't know Eulynx, it's basically the definition or standardization of the interfaces between a signaling system on one hand and all the periphery, ranging from RBCs to field object controllers. Now, data preparation is a bit of an odd one out. So let's dive into that now. Data preparation is all about defining what people need to build. That's our primary use case, because we noticed that when you prepare data for a resignaling project that the industry must then go and build, what we do today is we give them drawings and then they go and build it, they make errors, and it's a very wasteful process. So what you really want to do is paint this picture that you see here and the differences that should be built by numbers. That would look something like this. So you would initially have the data before and the data after, and then go and find the differences. Machines are very good at that, so that people can go out and actually do their work far more easily. Our goal is to make data leading, and the data should then be a single source of truth, whereas today often the images, the plans are the single source of truth, which is difficult because computers and algorithms, they don't really understand pictures, so you want to make sure that you have information, data that computers can understand. Next question is, what is actually data? And because data is not the same thing as information. If I tell you this is a signal, yeah, of course you do. When you see a signal, you know one. So there's more to it than meets the eye, and this is depicted here. You see a series of noughts and ones. This is data, but it's meaningless because you don't know what it means. And this is where the rail system model gets important. That's on the next picture. Eulynx decided to build on top of the rail system model, and in particular, the topology and topography parts of that model. Because Eulynx needs to define a number of things that people need to know. You see it listed here. We need to know how things connect, how tracks connect, how the objects on your railway network, how they are connected. That's something that RSM does very well. So you need to know where your kit, your equipment is located on the network, but also where you can find it as in terms of position on Earth. But that's not all. You also want to see where it is displayed on your screen, for instance. That's a different set of coordinates. And RSM is very good at doing that, actually. And finally, we want our data to be structured. We heard that before. People want to be able to query data. Other people want to be able to count it for bill of quantities. And then there's a very important use case that we want to see differences between data sets at different given moments in time. Yes. So the important message here is that we want to replace graphics, or we want to complement graphics really by an underlying data model. And the data is then source of the graphics that people can read again. So we don't do away with graphics, but graphics are just a front end to the data. We already touched upon this subject, but we want to do it again. That is, what's inside this rail system model box? Because I'm slowly going towards that application that we have in Eulynx. These UML diagrams that are the core of the rail system model, they provide this structure and meaning. So if you've got a data set of zeros and ones, plus you know what it means, then you can actually work with it. And if you take a close look at the UML diagrams, you're not supposed to do that here. That's why the picture is so small. Then you'll find that everything is very well described. The relations, there are a couple of relations that are very easy to explain. It takes you about 5 minutes to understand how this works. Then you have the full key to a data set, to understanding the information that's inside Eulynx RSM-based information set. Some added goodies is that inside the UML, we want to be a single source of truth for information structure. We put a lot of drawings, and because drawing, as you know, is worth 1,000 words. So this is inside the box. The question I often hear is, so we've got a nice new model, UML, ontology. How on earth am I going to use it? A few words about that now. Well, there are different ways of using it. One of the legacy ways of doing it is going from this top left-hand model, which is what's often called a PIM, it's not project, PIM, help me out, independent model. It's
Platform.
Platform, thank you. A platform independent model. We go to a so-called platform specific model in the middle, which is, for instance, an XML schema definition. And you lose some information on the way. If you go from UML to XSD, you retain the semantics, so you know what's inside the box. You retain the structure, the links, the hyperlinks, the compositions, all that. But you lose a bit of graphic documentation. Pity. The next step is, once you've got the XSD, then you want to actually fill it with life. You want to fill it with, instantiate it with data. That's what you see on the right hand. Again, if you have this XML, then you know what's inside they know what the information means. You can navigate back to the UML if you don't know what a given element location or whatever, what the definition is. Very important. Another option that we've explored is to take this very same UML and convert it into object-oriented code. Here I've typed in the example of C#. We generated a dynamic library for that, but you could also generate other dynamic codes such as Java or Python, if you wish so. That is something you can integrate into tooling. You can integrate C# libraries that were generated into, say, AutoCAD, and you can integrate it in other tools like Visio or open source tools that are yet to be developed. What this tool then can do is read or write Eulynx RSM-based XML. And that's going to be part of my final slide, and then I'll do a short demonstration of what this would look like. This is indeed an important message. The batteries are included. So you don't just get a model, but there exists an XSD, and also there are some code generators. Now, they do exist, but they're not quite released yet, of course, before you raise a question. So let's go to the final slide. So I want to show you how this would actually work in a real life experimental environment. I'm going to show you a small tool, experimental tool, that included said library that was generated from this UML model. And also we created signaling stencils, and in the stencil you would have shapes that you can drop on your page representing signals, tracks, whatever have you, for signaling important stuff. And then click on the button and you linearize your data. Well, let me show you how it looks. Let me try and bring it on. So many people probably recognize Visio in this picture. And what you're looking at is here, of course, is a fantasy station and lots of things. And come the designer and says, let me add an axle counter here. Where is it? Here is it. Stick it to the rails. Let's add another joint. Already got release. And what you're looking at here now, you can see the content of the data, which is taken from the Eulynx model. For instance, if I hover my mouse over here, it will display the data that comes straight from the UML. Same for a linear segment, which is taken straight from the RSM. Only has got a name and a long name, that's all there is to it. But the background, what you can't see, of course, is that the C# library is connected to these shapes. And I basically can design the classical legacy way. I can draw my my railway yard. I can connect together with positioned relations the linear elements that make up the topology, and then adorn, add the shapes that represent the classes, that instantiate the classes as they exist in reality. So you see, this is very visual. It's far more concrete, I hope, than what you see when you're talking about models. Next, maybe the crucial step is if I click this button, serialize, it will go through the drawing, pick up all these shapes and linearize this into XML code, which is, last trick, this is what you see here. So now I created a Eulynx file, which contains a really long list of entities. Each one represents, for instance, buffer stops, signaling devices, locations, definitions that come straight from the model. The XSD that's behind it also reveals the structure. And as you can see, there's no more pictures in it, but it did inherit the definition, the semantics from the model. So what we've just been looking at now, this small demonstration, is the fact that you have got a through-going model that you start from a UML all the way down to a visualization of your classes that you can drag and drop onto a stencil and then configure it, your instances of the classes, just like they are, including the semantics as they are in the model. And then you can actually marshal it to stay in, to remain in railway speak, into data. And then we know that these data actually conform to the original model. This is a very hands-on demonstration. There's a lot more I could tell you about Eulynx and Eulynx data prep, because it's a very big model. We've been working on it for up to 3 years now, because we've been reuniting the European railways. We've been drifting apart for 180 years. But for this talk, I just wanted to show you how you can actually navigate from a UML model all the way down via appropriate tooling down to linearized data. Okay, we're nearly 3 o'clock. I think I should end here. Thank you very much for your attention.
Thank you very much, Bob. Is there any questions for Bob? In the meantime, I will start sharing, but if there is any question for Bob, I don't see any at the moment.
Hello, I have a question.
Yes, please go ahead.
This Eulynx UML is available online for use? Currently, like RailML, we can use it. So
yes, the here hesitation in my voice, but if you go to the dataprep.eulynx.eu link, you'll find the UML.
Okay. Right.
Or at least the HTML view of it. We are planning to release, we are finishing the model by the end of this year, then we'll get some more quality controls, quality checks, and then early next year, we hope to release the first version of the official UML plus an XSD and maybe some extra tooling to make it even more useful.
Okay, thank you. We will be looking for it and to work with it. Thank you, Bob.
Thank you.
J'arrive plus à accéder à le. J'arrive plus à accéder au. Ah, ici. Ah, no, actually, I was on mute. Okay. Sorry, I was struggling with a bit with Zoom. So thanks again. I don't see there's any other questions on the. I can see the chat. So, will you deploy it in the whole of Europe?
Yes, very much so. Very much so. There's various levels of interest from all the big railways are participating. Deutsche Bahn, SNCF, Network Rail, basically everyone. And also we're getting some inquiries from outside Europe, from Indian railways. So the idea is that the whole of Europe migrate in the mid to long term to Eulynx. And another aspect is that there are many other use cases for handing out Eulynx data. For instance, if you're thinking of digital twins, by the way, and if you're thinking of running algorithms that use the data for other purposes than building a yard, then there is good prospects in here. Okay.
Okay, thank you very much, Bob. And I think sorry, what's mais je les vois pas moi donc. For those not familiar, could you explain what is meant by acronyms UML and XSD in this context?
Oh dear, yes. UML is a unified modeling language, which is a way of presenting knowledge useful comes from IT, but it's somewhat similar, I'd say, to let's call it ontology for IT people. And XSD is XML schema definition language, which formalizes the way in which schematizes the way in which you write XML. So when you provide an XML data set and you have a schema, then you can check that the data are correct inside your XML schema, inside your XML data set, sorry.
Thank you, Bob. We have a follow-up question from Marine that is very positive. Can we use it in academia as well?
Absolutely, absolutely. We already started using it in academia in European projects like performing rail for level 3 operation. So it's and we're looking forward to working with academia because you will be well, our guinea pigs, so to speak.
Thank you, Bob. We have a question from Zangshan Shao. Thank you for the very interesting presentation. After the preparation of data with RSM and Eulynx, what will be the next steps for this prepared data?
Well, the idea is that industry, signaling industry, that's what we're aiming at, will receive these data sets and then do their job in it. So today, if you look at how things work, they receive plans, paper plans in all kinds of different formats. They have to learn how to handle them because it's different in each and every country, and then process it. Once they receive Eulynx data that are unified to a great extent, they will be able to deploy more people on data sets for different countries. So that's a great benefit to industry as well. It's a uniformity, and you can one size fits most, so to speak. There's a question about AutoCAD I see here.
Yes, indeed, yes.
Okay, from Ramesh Babu. You're planning to use the available AutoCAD data instead of recreate the actual graphic using Visio-like tool. How will you validate the drawing in versus Visio? Delicate question. Now, AutoCAD is indeed has been used as a front end for data, and we provide the library so that people can integrate it into AutoCAD. People have done that already. I'm thinking of Rail Complete here, for instance, and what they do is then they map symbols, I think they call them blocks on AutoCAD. They map them to the classes that we see in the UML, and they do the very same trick, linearize the drawing into a data set. That brings me, of course, to how will you actually validate it? That's a difficult question because how is validation done today? It's people look at drawings, they look at listings, all kinds of different data sets. In the near future, we hope, that is a bit over the horizon, to be able to create algorithms that do the validation for us. You can do, for instance, can automate rules and regulations that say there should be a distance of more than 50 meters between a signal and a magnet, for instance, or a balise. That sort of rules it's ideal for verification. A tool like Visio probably shouldn't do that, but you can have IT tools that can do it for you. So there is a need for a whole plethora of algorithm software that is in harmony with the data set. Visio is only, as I see it, or AutoCAD for that matter, just a front end for your data. That's what it should be.
Thank you, Bob. And last question before we move to the final part of our program. What is the possibility of missing data in final results?
The probability, you mean probably of missing out data?
Possibility.
Possibility. Not sure whether you mean possibility or probability, to be honest. Yeah, that's probably is associated with the chance that you don't linearize data that you see. So you see it in the drawing, but it's not in the data. I hadn't thought of that. I'll take care of it. But
that's a question from Balbar. I think that's the intent. But
yes. But the idea is this Visio tool is basically a demonstration because we were asked So you've got this nice new model, and you're going to produce data. Is there a sample set? We didn't have it, so we created one.
Okay, perfect. Again, thanks a lot, Bob, for your presentation, and thanks for the people asking questions. We're gonna move now to the final part of our program. Thank you, Bob. And so the next steps. What are the next steps for both RSM and for the OntoRail project? So I'm gonna hand over to Eri for, if it works.
See, middle.
Sorry, it doesn't go in the right direction. Okay, yes.
Okay, well, it all fits in one slide. Concerning RSM, RSM is work in progress, and I think it will remain work in progress for many years, which doesn't mean that it's not usable, just the contrary. I think the more users there will be, the more work there will be to further extend, adapt, interface the model with others. So this is an absolutely normal situation. And I see work ahead in 5 domains. One domain is the structure. When comparing different existing models, like for instance, IFC Rail, Eulynx, RSM, and others, it seems that when we talk of, say, a locomotive, we are thinking of different things. So locomotive as a piece of rolling stock, I would say, on the drawing board, or something that is in a catalog of a manufacturer, or the actual instance of a locomotive that is actually running on a line at a certain point of time. So it is difficult because it's always the same word. It's difficult to take these notions apart. There should be, I think, a systematic separation of functional aspects, structural aspects, and physical objects. It is very clear, for instance, the case of trains. Train is maybe one of the words that is most misunderstood in the railway domain. And if you ask, for instance, UIC what a train is, well, UIC is taking care of the merits data set about train timetables. Well, a train is a circulation that will circulate many days in a certain year over a certain schedule and with given stopping patterns. So it's not the same thing as this particular train running today from Paris to Lille. And here we probably need to generalize that kind of distinction. So currently RailSystemModel is very much at the functional level. Much less at the structural level in the sense of catalog objects with definite characteristics, and even less at physical objects or instances that are most relevant to operations maybe or maintainers. So on the other hand, other models like IFC Rail are very close to the physical objects, I would say. So this is something we need to clarify in order to avoid confusion in the information exchange. Are we talking of drawing board objects or catalog objects or real instances in real life? And when I say instance, it's not to be confused with instances in the IT sense. So that's a big field of clarification that would also, if we solve it, help the assembly of different models. Then the substance itself in RailSystemModel is certainly not complete. As I said before, I was embarrassed nearly because we did not address telecom subsystem, and telecom is quite big on the agenda at UIC with FRMCS. So yes, Pierre, we are going to take care of telecom as soon as possible. Operations certainly too, because it's also one of the big fields for UIC, which is, as everybody knows, the association of many railway operating companies. Rolling stock is obviously missing, and project phasing that has been outlined years ago never saw the light of day, because so far we had difficulties using it, testing it. And this is where it is good to have proper tools, even for ourselves. And that leads me to the next chapter, which is tooling. It is essential, as Bob showed before, to have live models and sample networks, mock-ups, if you like, or even real networks as far as possible. So it was a complete change several months ago when I was first able to not only instantiate a model, but also put it on a map. It totally changes the vision. And so this work stream will certainly be continued, also with the perspective to open up the tool sets to all users, including academic. So it's a bit the same thing as Bob also experimented. Bob has put so far efforts on the schematic representation. And from the UIC side, we put efforts in importing into RailSystemModel existing infrastructure using OpenStreetMap, which is so far the best available open source usable geographic database for railways. And there are only a couple of uncertainties when there are tunnels, because sometimes you wonder how they got the geometry of tunnels from aerial photographs. But in generally speaking, open source is quite good a basis, and I could make successful imports from pieces of network in Austria and Italy and other places. So yes, the tool sets are going to be developed. And by the way, they are already open to one of the ongoing projects, Optima, which I mentioned this morning, and trying to collaborate with others on that. Documentation is definitely one of the important points, I think. We made good progress, also quite guided also by Eulynx in this field, because this is where the idea of putting explanatory views and notes all over the place in diagrams came from. So it's no longer the case that we have UML as abstract figures on one side, and then PDF or wikis on the other side, and you have to switch constantly between both. Generally speaking, the semantics, the meaning is enshrined in the classes themselves or in the attributes and associations. So it is conveyed by the UML model itself. And when you export the UML to XML formats, for instance, the notes, the diagrams will also be exported. There is no loss. The other aspect also, which is fundamental, is since we have a ontology version of the model of RSM, the other way is also to make sure that the documentation is accessible in the ontologies. So if you go to the OntoRail website, you will see that we successfully already imported the illustrative diagrams, etc. But this has to be done in a more systematic way, because it's partly handicraft for the time being. It works, but it should be automated as far as possible. So there is some remaining work here. And then finally, of course, the linking of models, because we found out, yes, that it was impossible to have a model of all models that will do everything for everybody. That doesn't exist. And participating in other projects like Links for Rail, certainly, yes. And IFC Rail, it showed that it was there are lots of riches, I would say, to gain from other environments, other modeling approaches, etc. So here the next natural links would be, if I may mention only two, RINF, the Register of Infrastructure, because For those who were with us at the very beginning, 2014 or even 2013, when the feasibility study was released, it was soon identified that the register of infrastructure would be one of the economically sensitive use cases. So certainly we should come up with a solution for RINF in cooperation with the agency as far as possible, because there is an advantage to be gained from infrastructure managers, at least in Europe. Then the other possible candidate will be transmodel. This is being discussed in Links for Rail. We definitely aim at the higher business capability levels like operations and commercial. So here transmodel has lots of useful things to provide, well structured. On the other hand, transmodel strength is certainly not the network representation. So here complementarity should be sought. And of course, this is certainly not a limitative list, because of course, I did not mention TAF and TAP TSIs, but I got them in mind also as a former member of the European Railway Agency. This is certainly not forgotten. And then I think, in fact, the most difficult thing will be to handle the appetites of lots of different stakeholders, because we are still working in a rather small team, which I hope will expand as soon as possible. So thanks for your attention.
Thank you very much, Thierry. So just to, oops, it doesn't work. Yes, okay. So unless, is there any specific question on the RSM future roadmap?
And one more remark, by the way, I forgot to say. We say RSM 1.2 for the time being. It's the traditional way of calling things. Considering the past experience, 2 years experience of expanding the model, associating it with others, I do not see roadblocks. I do not see the danger of having so-called incompatible versions or fundamental reshuffles of the model. So we had some discussions about that internally. We think that probably will not talk about X.Y versions for future versions, because it is not how it all works. We are working towards compatibility, not incompatibility. So there are better ways to characterize new additions, expansions, additions, improvements, than putting X.Y.
Thank you, Eric. So just to give also a brief overview about, so you saw from Bob's presentation that RSM is in collaboration with Eulynx, and Eulynx itself is a key building block to in terms of the RCA architecture. And the other components of future proofness for future command control and signaling architecture is the FRMCS angle. And so as such, from a very long-term perspective, we feel that with RSM, we have a good basis to provide support to key initiatives leading to the foundation of the future CCS plus. But if we look at in the shorter term future, so we already through the presentation of the usage of the OntoRail knowledge engine within Links for Rail, we indicated and showed how it was powering the common dictionary that is used within Links for Rail as an input to the Links for Rail conceptual data model. That being said, Links for Rail, as you remember, is actually more than the common data model. There is also initiatives around defining and verifying as well. So or integrating rather with ongoing system architecture initiatives into Shift to Rail, notably RCA. And as such, in practice, the conceptual data model and the system architectures that is done within Links for Rail are two related initiatives, to the extent that there is only one rail system. They are taking different angles at this rail system, and as such, they need to be obviously in sync in their when they are being designed by inside Links 4Rail. And what we foresee for the upcoming future is that there is, to that extent as well, a role to be played by the OntoRail knowledge engine in support of these initiatives. To first, in the form of the modeling recommendations that were briefly addressed prior during the presentation of the usage of OntoRail within the Links 4Rail, but also when it comes to the use of upper ontologies, notably the one related to system architecture, because if we do so and use the platforms that OntoRail offers to establish linkage between concepts, if we have a view of the system architecture in ontology form, and if we have a view of the system modeling in ontology form, then naturally we can start making linkings between the two. Now, before we delve more into on that particular aspect, one last thing that also I wanted to mention in the specific context of Links 4Rail, and that's one is more on the investigation stage, I would say, is the ability to have a direct transformation from ontologies to project-specific models, knowing that in the end, this would still be the CDM that would lead to the project-specific models, but it would just take the form of an ontology representation of the CDM and its transformation into the project-specific model, as compared to taking a step of moving from ontologies into a UML representation and then going to project-specific models. So that's one thing that that is being discussed, that we are investigating in the context of the next step for the OntoRail project. Now, coming back to this mention we're making about the relationship between architecture and modeling. So the system model that we see on top of this drawing on the right is essentially, in the context at least of Links 4Rail, that's what the work that is being done in collaboration between the work on the command dictionary and the work on the conceptual data modeling to unify and converge / federate models in one single conceptual data model. And that work, as explained before, is backed up by the use of ontologies within the OntoRail knowledge engine. The lower part of this schematic here is the work that is being done by the groups in Links 4Rail to actually devise the functional system architecture and using layered representation of the system and doing decomposition of the various layers and functions within those layers. But so this work around model-based system engineering does happen also to have a link to the notion of ontologies, because the tend to be formal representation of system, and as such the usage of there is actually for quite some time work done in terms of defining ontologies to support the MBSE processes, and as such the ontology link is here that we could also use the OntoRail engine to have a ontology representation of the system architecture within the OntoRail knowledge graph. And once we have the two, obviously, as you would have understood from the philosophy of the OntoRail knowledge engine, which is about creating a relation between concepts, we can then establish relationships between those two views of the system modeling aspect, and the system architecture, again through the use of ontologies. And so that work of making this this relationship is essentially taking the next step from having two separate views of both of the system modeling and the system architecture, and actually trying to maintain semantic continuity across those representation or those aspects of the railway system. And I guess that was mentioned by Gilles Desagnes from SNCF Réseau in his presentation. If we were able to maintain a rich link between a digital twin and system model that backs it up, then we can generate substantial gains in this process. Last thing we wanted to mention, but if there are any questions before we give the closing words to Pierre-Etienne, just wanted to highlight the various resources that you can leverage following this, that can be leveraged following this webinar. So the respective website of the RSM project and the OntoRail project, as well as the link to the OntoRail application, web application. And so following this webinar in a couple of days, we will distribute to the attendees the presentation that took place during this workshop, as well as provide information on most of the things on the GitLab for people that would like to interact with those various projects. And I don't see any specific comments or questions on the chat, so I think this will be appropriate time to pass on the mic to for his closing remarks to Pierre-Etienne Gauthier, who's the director of the BIM program in the SNCF Réseau, who's also the coordinator of the Eulynx 4Rail and Eulynx 4Rail 2 projects within Shift2Rail, and it's also the newly elected RSF sector chair of the railways digital modeling within UIC. So please go ahead, Pierre-Etienne.
Yes, thank you very much, Pierre. So I wanted just to start with saying a great thank you to you first, as because you really made the show today, and also to all the speakers because of the very interesting and rich material that was brought up. Not to forget also, because there are Alain, who was instrumental in getting all this done as well, and also getting this workshop, and also not to forget Marie and Estelle from UIC, also backstage, but very instrumental also in getting the participants around and the logistics. So just a few words to conclude. I think in this webinar, we've seen the power of ontologies, and there's a very much high potential ahead on the ontologies as a motor for getting interoperability and federating all the models, as we have seen, even architectures with the other models, but also in terms of having a connection to the other sectors in multimodal description of the other transportation modes, because we should not forget that sooner or later we are a part in a multimodal chain. The second, what I got also from this afternoon was the applications in the CDM of Eulynx 4Rail, and also the presentation that Bob made on Eulynx, where we have precise applications in the field. What we are looking there is interoperable models for data exchange and representation of the system that could accelerate and avoid proprietary systems and languages, and also having to, when we are redesigning some bits of our digitized system, whatever there might be, signaling or traffic management system, that we are obliged to redesign connector, which are cost consuming and resource consuming and time consuming, and sometimes don't work at first start. So there's a very, very high potential in getting through this federation of model, a continuous chain of interoperable tools, really for practical applications. So I think it's very, very promising. And we have also in Israel, we have the supplying industry on board. And I think we will have in UIC also to work maybe more deeply through Israel, but also with the industry to have the real implementation of this concept into products. Last but not least, I wanted to maybe jump on Gilles' presentation to say that on top of these representations of the railway system, we have also in the digital twin to describe the life of this railway system. And then we have another kind of models, which are the classical simulation systems we had in physical models, but now we have also artificial intelligence, and we can combine these models for having a better representation of the life of the railway system, and also the decision helping system that can help recovering from either small disruptions or larger events. So there's also a high potential in other types of model, but I think this is something we could have in a next series of workshops. So just thank you to everybody, and I think we hope to see you soon in future workshops.
Thank you very much, Pierre-Etienne, for these words. So it's time for closing this webinar. So we'd like to thank you all for your attendance and participation throughout this webinar. Thanks a lot for your patience this morning due to our unfortunate technical glitches. Thanks to our speakers for all their insights and shared experience. We'd like also to thank obviously the UIC personnel that will help us in creating this workshop, and a special thank you to Alain for bringing the torch forward on digital modeling for quite a number of years. So, thanks for that. On these notes, thanks again, and hope to hear from you soon on the subject of digital modeling. Bye-bye.